3x to the 4th minus x cubed minus 33x squared plus 71x minus 20 Okay, so from 2-4, let's list the possible rational zeros. Okay, so this is that P over Q business. Do you remember what P was? Factors of the... No, but P, the one on top of that are the factors of the constant. Okay? So this would be plus or minus 1, plus or minus 2, plus or minus, shouldn't go crazy there, 4, plus or minus 5. What's next? 10 and 20. And then Molly, the factors of 3, 1 and 3. Okay. So now don't leave it in this form. So the possible rational zeros then are plus or minus 1, plus or minus 2, all the ones on the top, because when you divide them by 1, don't you get themselves? And then I have to divide them by 3. And then you're going to be thankful that you have a calculator and you don't have to find them all by hand. And let's graph them. Now, technically, I guess I should go out negative 20 to 20. Why should I do that? Because it could be out there, but I'm gonna think it's those two. Yeah. Okay. So that means there's two real ones. What else does that mean? There's two imaginary, and they're a complex conjugate pair. Okay. All right. So let's first. This is good. We're going to be halfway done. Let's first verify the real ones. I'm going to zoom in again. I think maybe one was out. Nope. To me, that looks like negative 4. Does that look like negative 4 to you? Yeah, and then this looks like it's probably like 1/3 would be my guess. So let's verify. Negative 4 is a 0. And what did I say, 1/3 I thought? Good. Okay. So the farthest we're going to get today is to irreducible quadratic, and then tomorrow I'll show you how to get to linears. So what we do, and if you want we can take the easier one first. What this means is that x plus 4 is a factor, and x minus 1/3 is a factor. I'm going to rewrite that a little later. And that means what's left is going to be an irreducible quadratic. Okay? Tomorrow we'll learn how to get it to linear factors. We already covered enough today. What should I put in the box if I'm going to do synthetic division? Negative 4. Go ahead and do the synthetic division a second. Wait, what happened here? Whoopsies! Yeah. Thank you. -12. Okay. Okay, if I were to write this means there's a remainder of 0, which there should be. This would be 3x cubed minus 13x squared plus 19x minus 5. I'm not going to bother rewriting it because now I need to divide off the second 0. What would I put in the box the second time? Positive 1/3. And then I put these coefficients down. So I'm dividing now a cubic function by a linear function. What's going to be left is a quadratic, and that's that irreducible quadratic that I was talking about. All right, what's 3 times 1/3? How about -12 times 1/3? And then 19 plus -4, 15. Multiplying by 1/3? Yeah, isn't that the same as dividing by 3? Okay. Alrighty. So, now, this is 3x squared minus 12x plus 15. Is this linear and irreducible quadratic factors? These two are linear. Why do I know that that's irreducible quadratic? When we looked at the graph, did we see any more zeros? No. So that means these are complex. Tomorrow what we'll learn is how do we find the two complex. You really know. You would do quadratic formula, yeah. Okay, one last thing then. Is that really the right way I should write that? X minus 1/3? Nope. So let's write this in factored form with integer coefficients. X plus 4, multiply these through by 3. That would be 3x minus 1 and 3x squared minus 12x plus 15. So you just factored a cubing function into another function with real coefficients. Okay, so if I ask you to factor something into its linear and irreducible quadratic, that's what I would mean. At that point, you would stop. How did I get what?
1/3 of 3x. That is
if you want to change these to real or to integer coefficients, you multiply both terms by the denominator. So I multiplied x by 3 and 1/3 by 3. X is 3x, and then 1/3 times 3 would be 1. Okay, let me give you your assignment then. Let's open our book so you can see the instructions. polynomials, and then stating how many zeros something has based on the degree of the polynomial, and looking at the graph to see if they're real or imaginary. So it doesn't involve any of the synthetic division. And then the ones that I want you to do as linear and irreducible quadratics are 37, 39, and 41. Then tomorrow we're going to actually take this example and continue it forward.